I'm going to go through an example problem of working with relations. A relation is a group of ordered pairs, and the smiley face here will represent my relation so far. So the first question says, write the relation graphed as a table. So here's my XY table, and whenever I do this, I have to remember the x value should be written from least to greatest. And I'll look at my first x value. I have a 2, 3, so that'll go in here. And then I have a 3, 2, and a 3, 7. So my default is to do x values least to greatest, and then if I have two x values that are the same, I'll do y values from least to greatest. So my next one will be 3, 2, and then 3, 7. And maybe I should start ticking these off. I got you, I got you, I got you. And now I'll be doing 4, 2, and 4, 5. And that means you're done and you're done. So I've got 5, 2, running out of room, 5, 7, and last but not least, 6, 3. Okay, I fit it. So this right here is a graphical version of my group of ordered pairs, and this is a group of ordered pairs in a table. I'll now state the domain and range. The domain is all x coordinates or x values. The range is all y values. There are some rules. These should be written least to greatest with no repetition within them. A domain is a group of numbers, so I'm going to put this in set notation. I'll open up a brace, and it'll be my x values least to greatest with no repetition. So I have a 2, 3, 4, 5, and 6. Again, I could look here, 2, 3, 4, 5, and 6 is all represented within that. My range, all y values, is going to be least to greatest, so I'll look here. I've got 2s, 3s, 5s, and 7s. 2s, 3s, 5s, and 7s. I could have searched through here as well and found them least to greatest with no repetition, but that just looks like an eyesore. To me, it seems easier just to say I've got some 2s, some 3s, some 5s, and some 7s, and look at the graph to get my range. Okay, now I'll state the inverse. Well, the inverse is a transformation. It takes all of your ordered pairs and changes them according to this formula. And it's a very easy formula. It's just all xy values go to y comma x. Sorry, that looks like there, y comma x. So I'm going to take all of these and I'm going to rewrite them as a set of ordered pairs, which is a brace, and then, oh my goodness, a lot of these things. Let's see, how many of these do I need? 1, 2, 3, 4, 5, 6, 7, 8. So I've got 2. Okay, bear with me here. 3, 4, 5, 6, 7. Move over, buddy. 8. Okay, now I need to reverse these ordered pairs. So I'll start with this one. 2, 3 becomes 3, 2. And again, this is the inverse. Next one would be 2, 3. That's this one. And then 7, 3. That's that one. And then 2, 4. Okay. And then 5, 4. And then 2, 5. So once again, I am just following this all the way down here. So I was at that, now I'm at 7, 5, and last but not least, 3, 6. Okay, that was a pain. Alright, I now need to get rid, oh, I didn't want to do that. I want to get rid of the highlighter. I want to get rid of the green. You might, oh no, just kidding. Okay, get rid of the green. Maybe try an eraser. No, I'll pull them. There we go. You may be asking, why am I pulling all that away? But I know something you don't know. Okay, now let me group all of those. Oh, no. Let me group all of those. and I need to clone them. Let me see. Come here, buddies. And I'm going to take them down here with me because I need them for another problem. Come here. Hey, come here. Okay, there we go. All right. Now, I have a reminder right here, and I'm going to read that, and that has to do with this inverse. It says, remember, this set should be enclosed by, well, what are they enclosed by? They're enclosed by these things. And what are they called? They're called braces. Okay, there's my reminder. So why did I spend all that time dragging this down? Well, I wanted you to be able to see my table as I made a mapping. And a mapping is sort of a Venn diagram of sorts. I'm going to put all my x values in this bubble and all my y values in this bubble. It says down here, remember, the domain should be written from least to greatest. How do you spell greatest? There it is. And both groups should have no repetition. So I'm going to go least to greatest. 2's, okay. That's not how you spell 2. Hold on, I'll try that again. 2, 3, 4, 5, and 6. Okay. And then the y values, it only says domain least to greatest. You see that there? The domain. How do you do the y value? Well, I'll tell you what I do and what most people do. You try to follow this as best you can, but you don't repeat. So I will have a 3, then a 2, then a 7, and I won't include that 2 because I already have one, and then a 5, and then I've already got a 2, I've already got a 7, I've already got a 3. So that is going to be my y bubble. Okay, here's the last part. The last part is connecting them. Right here, the 2 goes to the 3, so I'm going to say the 2 goes to the 3. The 3 goes to 2. There it is. 3 goes to 2. The 4, oh wait, I'm not at 4 yet, am I? I have to do another 3. 3 goes to 7. So 3 goes to 7. Got you. 4 is supposed to go to 2. I'll bring you back up there. 4 is supposed to go to 5. I'll bring you down there. 5 is supposed to go to 2. Bring you up there. 5 is supposed to go to 7. I'll bring you down there. And 6 is supposed to go to 3. I'll bring you up there. Ha! That looks crazy. Now, why would we do a mapping? Mappings are used for function identification. Used to identify functions. That's not how you spell function. Function. Okay, now, we haven't explained functions yet. We're just getting into the basics of relations. But we have to practice these now, so when we start talking about functions, it makes more sense to determine them. All right, then last but not least, determine whether the relation is discrete or continuous. Discrete means a distinct separation of points. You can actually see a gap between points. A continuous relation has no separation of points. Separation, I'm just going to pretend that says separation of points. Sorry about my handwriting. When do we see discrete data? Well, points on a test is discrete data. You get a 92%, it's an A. You get a 91%. In our school, it's a B. Continuous data, you see when you're measuring temperature throughout the day, it just never stops moving. The temperature is always adjusting slightly. So that would be an example. Okay, well, what else did I... Oh, yeah, what's this? Well, clear separation of points up here. So I would have to say that that is a discrete relation. Okay, I think I got it all. Lots of definitions in there. Enjoy yourselves. Bye-bye.